Okay, good morning, everyone, and welcome to our third Tech Talk, exploring occupational safety and health administration for manufacturing. So we'll be looking at the focus of the OSHA implementation in manufacturing settings. Next slide. I'm your host, Marilyn Barger, and my colleague is Laura Sharp. Laura's from the St. Petersburg College and is the program director for engineering, manufacturing, and building arts. And I'm the director of the FLATE, the Florida Advanced Technological Education Center, which is part of the Florida Makes network. Next slide. We bring these to you, this series, this Tech Talk series, with support from the Florida Department of Education under their Strengthening Career and Technical Education for the 21st Century Perkins 5 Act under state leadership. Next slide. So what is FLATE? So FLATE's an organization within the Florida Makes network that works with primarily the two-year college, technical college, and the high school programs that support manufacturing in Florida. And our vision is to provide Florida's workforce with manufacturers with a world-class workforce. Next slide. And we do that and put our work in like 3 different buckets. We work in reforming curriculum and developing new curriculum. We work with educators for providing them professional development to stay up to date on new technologies and new pedagogies, new ways to teach, as well as new content. And we also work closely with them and the community, the manufacturers, the schools, to recruit and retain students in these programs. Next slide. And here's our brief agenda. We're just going to do our introductions, introduce our speaker, and then Mike Innes is going to give his presentation. We'll talk about some resources and Q&A. Right now, I'm going to turn it over to Laura, who's going to introduce our speaker and get you all started. Laura?
Thank you, Marilyn. All right, so to begin with, I'm going to introduce our speaker, Michael Innes. And Michael is currently a business advisor with the Economic Development Commission of the Space Coast and also Florida Makes. Michael holds a Master of Science in Management of Technology from the University of Miami. He has been working in manufacturing since 1982, after 6 years in the U.S. Navy serving aboard FLATE ballistic submarines. Michael supported the space shuttles as an engineer for McDonnell Douglas for 19 years at Kennedy Space Center. He then went to Washington, D.C. as a project manager for Total Resource Management. Here, he led project teams installing the Maximo software at naval bases and veterans hospitals along the East Coast and Midwest. After 5 years, he went to Harris Corporation in Palm Bay, Florida, where he worked as an engineer until 2020. Michael has also been an adjunct professor at Eastern Florida State College since 2005, teaching engineering courses in the evenings. So obviously we have someone very, very well qualified for the talk today. And to help Mike get a sense of our audience, we have a couple of poll questions. So the first one is, we want to know, where do you work? So that poll should pop up and take a couple seconds to answer it. Five, four, three, two, one. Let's see what our results are. There we go. Oh, well, wow, even split. So we got post-secondary, manufacturing, and other represented today. Thank you. And our second question is, we want to get a sense of how you interact with OSHA. So do you work with it or do you teach it? Five, four, three, 2, 1. So most of you are affiliated with interacting some way with OSHA. Fantastic. All right. Well, thank you for that. And now I hand it off to Mike.
All right. Thank you, Laura. Thank you, Marilyn. And thank you, FLATE. I appreciate the opportunity to chat with you guys this morning. So let's see. So does everybody still see our pictures up here? So we can have those go away, I guess. All right.
Yep, it's just you.
So we just see the screen now? All right.
Yep.
Well, again, good morning, everybody. My name is Mike Ennis, and like Laura said, I'm currently a business advisor for Florida Makes and EDC. Had a lot of experience in manufacturing, and also with OSHA safety. So today I'd like to speak a little bit about how OSHA and Industry 4.0 technologies interact. So what we're going to talk about with Industry 4.0 and safety, we'll also talk about some of the available training tools that OSHA has online, and we'll talk about how to improve safety, risk management at your company or to teach. So, okie dokie. So it's not going to the next slide. Thank you. There we go. All right. I love technology. All right. So what is Industry 4.0? Right? It's the fourth leg of the Industrial Revolution. Industry revolution started with the advent of steam and water-powered machines. We came into 2.0 was the mass production and assembly lines using electricity. Then 3.0 was when we stepped into our informational technology and automation period. And today we're advancing even further in manufacturing and industry, where we're getting into cyber physical systems, smart manufacturing, cloud computing, and artificial intelligence. So let's look at the timeline of how we've progressed. So the first industrial revolution came about between the 1700s and the 1800s. We went from manual labor performed by people, aided by work animals, such as oxen and horse. And we have even had dogs that helped in industry. And they provided the power. And the horse helping us do the work, that's where we came up with the term horsepower. So it's actually what one horse could do. So to the labor performed by people, aided by the use of water and steam-powered engines and other types of tools, is when we started moving into Industry 2.0, the second industrial revolution. So in the early part of the 20th century, the world entered the second industrial revolution with the advent of steel and the use of electricity in our factories. All right. So the introduction of electricity enabled manufacturers to increase efficiency and to help the factory machinery more mobile. It was during this phase that mass production concepts like the assembly line were introduced as a way to boost productivity. The third industrial revolution started in the late 1950s after the Second World War. The third revolution slowly began to emerge as manufacturing began to incorporate more electronics, right, and eventually computer technology into the factories. During this period, manufacturers began experiencing a shift that put less emphasis on analog and mechanical technology and more on the digital side of technology and automation software. So today we're moving into the fourth area of the Industrial Revolution. So in the past few decades, a fourth Industrial Revolution has emerged known as Industry 4.0. It takes the emphasis on digital technology from recent decades to a whole new level with the help of interconnectivity through the Internet of Things. And you'll see that acronym is IoT. The access to real-time data and the introduction of cyber-physical systems. Industry 4.0 offers more comprehensive, interlinked, and holistic approach to manufacturing. It connects physical with digital and allows for better collaboration and access across departments, partners, vendors, products, and people. It's estimated the next level of the Industrial Revolution will be 5.0, where people work alongside robots and smart machines. It's about robots helping humans work better and faster by leveraging advanced technologies like the Internet of Things and big data. Okay, so we know we're in the COVID pandemic now. For the last year, things have been quite unique in manufacturing. So Industry 4.0 technology is being used to ensure that employee safety is on the shop floor. Personal protective equipment, for example, can include the Internet of Things, sensors that send alerts when workers come within 6 feet of one another. The IoT describes the network of physical objects, or the things, that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. So Industry 4.0 is also being used to automate processes in ways that keeps employees out of harm's way, while also improving productivity. Before going into an unfamiliar job or situation, for instance, operators can train with virtual reality. Particularly dangerous aspects of jobs can be entirely automated with robotics. Tedious and repetitive jobs can be automated too, such as moving goods through a warehouse or doing quality checks on the production line. Increasingly, organizations are automating warehouse logistics with robots that calculate the fastest route from point A to B, while humans work directly with the robots to optimize warehouse operations. Expect more of the same even after COVID-19 passes. An automated work area, such as a warehouse, uses multiple sensors to gather data to manage the work area. Data from facility systems, such as ventilation and lighting, is used to optimize the use of energy, reducing the heating and cooling in an area where no one is present, or maintaining low temperature to cool electronic systems, reducing downtime of equipment by monitoring wear on equipment to schedule preventive maintenance. Data from product packaging containers track product within the facility, prepares shipping documents, and delivers product to loading areas for shipment. Data from support tooling generates a warning signal to employees if they're in a potential hazard. All right, here's a question for you guys. Can you identify an application where Internet of Things sensors could be used either at home or in your workplace? Type something into the chat to give us your idea. Okay, 5, 4, 3, 2, 1. Everybody got something in? So what are some of our suggestions and ideas?
Okay, well, okay, I'll take that.
Okay,
we have only one from our audience, and that's the Amazon Alexa. That's a good, really good example, but certainly
Absolutely.
all of the certainly all of the smart devices we now have in our phone, like turning the thermostat up or down in your home before you get there. The Ring doorbells might be another one, or the Nest that's just popped in as ideas. There's quite a few. I think that we all are experiencing every day, different levels of technology. Okay, great.
Okay,
Thanks,
excellent.
everyone.
All right, thank you. So as you know, it's kind of your imagination is the limit, right? We can create sensors that do a lot of things for us at home, and as well as a lot of things in the workplace. We can in the workplace, if we're on an assembly line, we can actually have sensors that check the tensions and thicknesses of belts, so that instead of typically in preventive maintenance, you would, like, every month you'd take the assembly line down and do a little bit of work to it to make sure the belt is good. So that would create downtime. But now with the Internet of Things, the sensors that we use, we can actually gauge when we're going to bring the machine down or the assembly line down when it actually needs the maintenance, instead of forecasting out preventive maintenance. So it's less downtime for our machinery in the workplace. So, and that's a key to manufacturing. You want to keep your machines up and running as long as possible. So excellent, good ideas, thank you. All right, so how does safety come into play in the modern manufacturing area and in industry? All right, we going to look at how computers, automation, and robots work in, and then the human element. How do people work beside the automated equipment? And then we're going to talk a little bit about lockout and tagout, because that's OSHA's way of ensuring personnel are kept safe when working around equipment. All right, so the Occupational Safety and Health Administration was established in 1971 by President Nixon. Since then, OSHA and state partners, coupled with the efforts of employers, safety and health professionals, unions, and advocates, have had a dramatic effect on workplace safety. Fatality and injury rates have dropped markedly. The purpose of OSHA is to ensure workplace safety, protect employees, and hold employers accountable for workplace hazards. OSHA standards are sets of guidelines and instructions introduced by the Occupational Safety and Health Administration to minimize hazards and health risks in the workplace. OSHA standards are regulatory standards required by law. So keep that in mind as we talk about some of the things that are coming up. The OSHA standards are laws. One thing to keep in mind, there is no OSHA robot standard. Okay, however, OSHA references the ANSI standard R15.06 for being the standard applicable to robot systems. Okay, ANSI is the American National Standards Institute. All right, it is the sole U.S. representative and dues-paying members of the International Organization of Standards. As you got, ISO, right? We all know what ISO is. So ISO standard is a set of internationally recognized guidelines covering key areas of running and managing a business. So ISO standard 10218-1 is safety of robots, and ISO standard 9409-1 is the mechanical interfaces. So this is all part of global harmonization. This has come about with ISO has set up a global network of standards. So instead of OSHA creating the robotic standard within themselves, they partner with ANSI and ISO to give us a standard. Okay, what's the impact of automation on the workplace? It's intended to enhance productivity, quality, and competitiveness. So how does this automation affect our workers? So a changing emphasis on physical work to mental work, that's how it impacts us. It reduces the number of employees per task. It eliminates some jobs, and it also, the downside, it increases the level of stress on workers, supervisors, and managers, because now you have to think more than act, right? So in the pictures below, you'll see a routine task that at one point, picking up garbage and waste management throughout cities, it took 3 employees, right? You had to have a driver of the truck, and then you had to have 2 loaders that would pick up the garbage on the side of the road and put it in the back to be compressed. For those of you that are old enough to remember this, you also remember that those 2 workers on the back used to ride on the bumper, right? They'd hang on to a bar and ride with the truck just hanging on. So that didn't sit real well with us either, right? Those employees were at risk all day long. So now we've created the trucks and the new trash cans that the truck can pull up. You only need the driver. The robot arm comes down, the driver picks up the trash can with his manipulator, dumps it in the truck, it's compressed, sets the trash can back down, and moves on to the next house. So we've gone from 3 employees to 1 employee, and it's a much safer operation because nobody has to get out of the vehicle. Okay. All right, so human and robot interaction. Okay, every new tool we develop to enhance the ability of humans to work efficiently and effectively has brought about with it a new safety and health hazard, right? Anytime you have a new procedure, you got to look at the safety and health hazards that are created. So robots, they add to potential hazards in the workplace due to their intelligence through programming, their flexibility and range of motion, and the speed of the movement and the power behind it. Okay, so here, let's have another question for our audience. Does anybody know what the main parts of an industrial robot are? And how fast do you think a robot arm that's got 6 axes can move? Give us your best guess on this. Put it in your chat, please.
I'm not sure we're going to get any guesses. I don't know those answers either.
Okay, well, let's go right on and talk about it. So a robot arm, okay, you have the manipulator, which is the main arm itself, right? Then you have a sensor that is on the end of the tooling. The tooling is what's at the end of the manipulator. It's, let's say, the hand that's on the end of the arm. The sensor is the fingers, okay? And everything, all the readings go back to the controller. So if you want to look at it like a person, you've got the controller, which is the brain, the manipulator, which is the arm, the tooling, which is the hand, and then the sensor, which is the fingers. So the robot can sense what it's picking up and move it. And a 6-axis arm is capable of speeds up to 1 meter per second. So if you've ever seen videos of a manipulator arm working in a plant, they're fast. I mean, you got to be careful working around them because they can move real quick. So with this new manipulator arms being used in our industry, and they're used all over, almost all manufacturing that's has an up-to-date plant is using arms. So here's a photo of how some arms are working with people right there beside them. So what kind of things can happen? You can have an impact or a collision, right? That's when the arm does something that the person doesn't think it was going to do, right? An unpredicted movement. The second one is crushing or trapping. And that's a really big hazard because if the person is in between a solid object and the arm moves at a time they don't think it's going to move, it could pin you between the solid object and the arm and the arm having enough power it could crush you. The arms being mechanical, you can also have mechanical part accidents, okay? We all know machines break, right? And sometimes you have breakdowns of the components. It can be catastrophic where parts flaw off. So we have to be careful of that. And then you can have other accidents, such as equipment that supplies robot power and control represents a potential electrical or pressurized fluid hazard. Ruptured hydraulic lines could create dangerous high pressure cuttings, streams, or you could have whipping hoses in the workplace. All right. So how do we prevent a trapping issue? You can have a potential crushing issue with the arm moves and you're caught between a solid object, like I said earlier. So when working around robots, we have 3 zones. We have a safety zone, and that's the zone that's totally outside the reach of the robot. A person can walk in that area and the robot could extend to extreme length and it wouldn't hit you. All right. Then you have the caution zone. That means it's an area that's usually taped off around the robot saying, hey, one more step and you're in the danger zone. So it's to caution the employee from going too close. And then within the danger zone, that's where the robot can hit you. It can pin you. The robots are going to do what they're programmed. So if you step into that danger zone, the robot don't see you coming. So it could, you could have an impact with the robot impacting you. So we want to stay outside of the safety zone or outside of the danger zone, stay in the safety zone. So how do we create safety measures around the robots? All right, we construct fences around them and have hinge gates, like a switch that's on the gate. If you go in, it powers down the robot. We can also have controls that control the speed of movement. If you don't need that robot going at 1 meter per second, you can slow it down so that the employee has time to move. If for some reason they have to interact with an energized robot, we can get it slow enough to where you can avoid any impacts. You can install emergency stop devices. And you always want to locate these controls outside the safety fence, right? You don't want to have to go inside the safety zone to de-energize the equipment. And we can also establish automatic shutdown switches. It's like the light curtain down in the bottom right of the picture. So if somebody walks too close to the machine, if they go past the caution zone into the danger zone, they break a light beam and that shuts the machine down. So out of all these, that hinge switch, putting a fence around the robot and putting a on-off switch on the gate is kind of your least expensive way to manage your robots and work them safely. So what are some of the challenges that employers are facing with workers and robots working together? So you have to ensure that the workers are trained, right? That's the key. Everything really revolves around training, employee training. Employees have to know what is the potential hazards. You can't assume they all know. So here, I've dug up some actual events that happened through history, right? So in 1979, a gentleman named Robert Williams, he was the first American to be killed by a robot, right? Then I think we have an attachment that will take you to the actual article if you want to read more about it. And then at the VW plant in Germany, a 22-year-old worker died after an accident involving a robot in the Volkswagen production plant. According to the spokesman for the company, the contractor was in the process of installing the stationary robot when it grabbed him and crushed him against a metal plate. So he was a contractor that should have known how to use this machine, evidently plugged it in and energized it prior to it him being out of the way, and the machine activated and crushed him between a plate and the arm. So you've really got to be paying attention to what you're doing. So here's an example of how OSHA steps in, okay? A manufacturer in Alabama lost a worker and had to pay $1.5 million in fines. That's how OSHA steps in after they've investigated an accident. If they find the company negligent, they will fine them, right? So this article again is on our references that you could click and look at. But basically what happened, they were working on the robots. Managers were standing around, engineers were standing around watching the workers go in and out of the work cell. They didn't tag anything out. They did not use lockout or tag out. So they were doing the work. Nobody said anything about taking the power down. And one of the arms moved when the employee didn't think it was going to move and crushed it. So the key is that the managers and engineers were watching the workers work in an energized robot area. And that's, you don't want to do that. That's why they got the $1.5 million fine. So this accident could have been prevented by the use of lockout and tag out, okay? This is one of OSHA's, to me, one of OSHA's most important standards. They're all important, the ones OSHA has put together. The lockout and tag out will save lives of workers working on equipment. So they estimate that 122 fatalities, 28,400 lost workday injuries, and 31,900 non-lost workday injuries. That's where somebody gets hurt, but they don't have to go home. They were prevented each year by properly using the procedures contained in OSHA's lockout tagout. So it's been proven that lockout tagout works. So it should be used. So how do we operate lockout tagout? Okay, LOTO is the acronym for lockout tagout. So lockout, the lockout portion of it is the act of blocking the flow of energy from the power source to the equipment. Tag out is the act of warning or putting a tag on the equipment that is being worked on. Do not energize. So the lock physically prevents somebody from re-energizing the equipment, and the tag out tells them why is it turned off, who's got it turned off, because you put your name on it, and they know who to come to get the tag out removed when the work's done. And then think about it, the principles of this can also be used at your home. When you're working on something at your house, like let's say your garden sprinkler pump or your pool pump, it just doesn't sound right when it's running and you want to go look at it. You want to make sure you go to your circuit breaker panel and de-energize that piece of equipment. I know a lot of people can say, well, I know not to touch the wires, right? But if it's making funny noises, you may have a fault inside the case that when you go to touch the case, you become part of the circuit. And that's not good. So you always want to make sure that even when you're home, think about lockout, tag out. It could save your life or your kids' lives, right? If they're around watching you do the work. Excuse me. All right, the purpose of the lockout, tag out procedures is to prevent unexpected energizing or starting of the equipment, right? You don't want to be working on the equipment, have somebody come in and turn it on while you're sitting there working on it. And it prevents the accidental release of the stored energy. And keep in mind that the energy can be hydraulic, pneumatic, it can be steam, it can be the electricity that we typically think about. Any type of stored energy you have to release. Sometimes you have to go to the check valve, right? Open the check valve and release like the steam energy, or do a bypass valve to bring down the hydraulic pressure, because energy is stored in machines. So if you're working on it, you have to make sure you've gone through all the circuits and the systems to remove the energy before you start disconnecting hoses, wires, things like that. So the energy, I kind of went ahead and answered the questions for you, right? So energy is any type of power that goes to the machine, and the energy source would, like in a hydraulic system, it's the hydraulic accumulator that is building up the pressure for the hydraulics to work. If it's a steam system, it's the boiler that's creating the steam from the pressurized system. If it's electrical, it's a circuit breaker supplying. So those are the different energy sources you need to always look for. All right, the scope and the application of lockout tagout is employees performing service or conducting maintenance on a piece of machinery. It needs to be locked out and tagged out. All right. It's important that the company abides by the regulations, and failure to follow lockout tagout procedures can cause injuries and fatalities. It can cause fines to be levied on the company. It increases all expenses related to the manufacturing processes. So hazardous energy exists, and or unexpected startup could occur. You want to make sure you do lockout tagout. Nowadays, with the Internet of Things, sensors can start and stop machinery. So you have to be aware of all those sensors and de-energize those as well. You need to do lockout tagout anytime you have to remove a guard or bypass that guard. You have to do lockout and tagout anytime a body part can possibly come in contact with equipment. And you have to do lockout and tagout when your body physically enters the danger zone of the piece of equipment that's being operated or being worked on. Excuse me. Okay, so lockout tagout devices have spawned industries within themselves, because everything that can secure or supply power in any way, shape, or form has to have a lockout device designed for that piece of equipment that is durable, they're standardized, and they're substantial, right? They gotta be able to hold and not just fall apart. And they have to be identifiable. So it's got to have a place for the lock, for the tag. So like you see the valve there in the photograph, that cap has to be able to fit around the valve. So as you know, valves are all different sizes. So we need to have all different size lockout devices. So total, you know, there's a lot of industries that just make the lockout device. So here, there are some exceptions to using the lockout and tagout. All right, if hazardous energy does not exist on the piece of equipment, right? If it is a hand-operated piece of equipment that when you're not operating it by hand, there's no power, so you don't have to lock it out or tag it out. If it's a cord control device, right? You reach over, say you're using a power drill, it's not working, or if you need to change the bit in the chuck, you unplug it, right? So if it's a cord control device, you don't need to use lockout tagout. All right. Limited hot tap operations, and that's where you're doing a small repair by welding something onto the frame of the machine. If you're not involved in any of the pipes or the tanks or anything under pressure, you don't need to lock it out. And then doing routine or normal production processes like running a print and press, minor tool changes or adjustments, like if you're running the old style printing presses, if you have to adjust the font left or right, you have wheels that help to do that, so you don't have to lock out, tag out the machine when you're doing those type of operations. All right, so the procedure, typical procedure on applying your lockout and tagout. First, you perform a shutdown, okay? That means you go and you look for all your energy sources. And keep in mind, machines use a lot of different types of power, right? You can have steam, hydraulic, pneumatic, electrical, spring-loaded. Think about your garage door at your house, right? I always, when I teach in a class at the college, I always talk about two things in your house. That's your water heater and your garage door. They are potential killers if you mess with them and don't know what you're doing. Because the spring on a garage door can come unwound, and the cables and the spring itself become objects that can strike you. So you really got to be aware of spring-loaded devices and weight-loaded devices, things that are using weights with gravity to move things. So once you release a cable, if the weight hasn't been lowered down, you can release that cable. If it's still underweight, now you've got a weight, uncontrolled fall to the ground. So all these things you have to take into consideration when you're doing your shutdown. Your next steps are to isolate the equipment, right? You've gone and released all the stored pressures by bypassing the pressures going back to the tank, or you've shorted out your capacitors that have stored power. The things that you need to do to save the equipment, you've already done. So now you apply your lockout tagout devices. First, you put the device on the switches that energize the equipment or provide power to the equipment. So you've got those devices on, and then you put on your locks, you put on your tags, and on your tag, you want to put your name and the equipment that was tagged out, the reason it's tagged out, and the date and time it was tagged out. And on these lockout devices, if you look down in the picture in the lower right-hand corner, you'll see a little clamp that's got 6 holes in it. Most factories will use that device. When you put your clamp, your locking device on, you put that clamp on, and then you put your lock in one of the holes. And that way, somebody else can come behind you and tag out that same system by putting their lock in that clamp. So you can have up to 5 people locking out that piece of equipment at the same time. You never, ever put a lock in the 6th hole. If you're the employee number 6, you come up and put another clamp in that 6th hole, and then you put your lock on your new clamp. Because then if somebody comes behind you, they have somewhere to apply their lock. When you're done with your work, you reverse the steps. You remove the lockout tagout devices, you start opening your supplies for power, and you re-energize the equipment and run tests to make sure the repair has been done correctly. So the employee that puts the lock on is the only employee that should remove the lock. However, we do have situations where a lock could be applied and the employee is no longer there at the company, right? So what the employer has to do, all right, you verify that the employee who applied the device is not in the facility. All right, you look for them, you try to find them, say, hey, are you done with the work? We need to turn this piece of equipment back on. All reasonable efforts have been made to contact that employee and inform them that the locks are to be removed, because before you do this, you have to verify that the equipment is sound, up and running, and then you ensure the employee has the knowledge before they go back, and if they go back and try to resume that work. This typically happens today when an employee is doing maintenance on a piece of equipment. They have to order a part. The part takes several weeks to arrive, and the employee, being a person, they find a better job or another job. So they go off to work in another job, and they've left the piece of equipment locked out because the piece of equipment doesn't have the part. Once the piece of equipment comes in, another employee can go to install the piece of equipment, the repair part, and then they'll have to remove the lock. But you have to go through your steps to make sure everything is safe before a third party removes that lock. All right, let's talk a little bit about the human element in occupational safety and health. All right. The one big thing nowadays is ergonomics. I'm sure everybody on this call has had classes in ergonomics or had software that talked about ergonomics. So in January of 2001, OSHA, they issued a long-awaited final rule on ergonomics. So they came out with the ergonomic program standard. It's 29 CFR part 1910.900. I mean, we went a long time without having anything from OSHA on ergonomics. See, ergonomics used to fall under the general duty clause. So employers could kind of sort of do whatever they thought was right. But now we have the OSHA standard. So the new standard contains very stringent requirements for most non-construction employees to identify and abate, reduce the musculoskeletal disorders that come about from ergonomic issues. So ergonomics, that's a multidisciplinary science that seeks to conform the workplace and all of its physiological aspects to the worker, right? So we're making the workplace fit the worker. Some of the issues we could have are video display terminal issues. We found out that looking at video display terminals, your eyes can, they get tired, right? The first thing is they get red, they get tired. You can even get into seeing double vision, dry eyes. Staring at a terminal or a video display for long periods, we all know that you need to take breaks. We even have software now that will pop up every couple of minutes and say, look away. It'll come up on the display terminal and say, look away. So all those things are good, right, to reduce the amount of video display terminal issues. So some other ways you can fix the terminal issues is you get a better computer, right? You get one with faster processing speeds. I know back in the old days when I was a young man, you're looking at a video display terminal on a piece of equipment and the refresh rate was not really fast. So you would see lines going through it. There would be fuzzy moments and all that tended to make it harder to read. So nowadays with the better computers, the faster computers, the more increased capabilities of the displays, it's easier to read one because you don't have all the flicker and flashing going on. And like I said before, you need to take breaks. Just look left or right, avert your eyes, look at something else on your desk or in your workstation, look at that photo you have of your family, and then look back to the screen. That changes the focal length of your vision and helps your eyes adjust. And the key thing is to have your workstation properly set up per the ergonomic standard. I mean, there's distances that are optimal to have the keyboard from you, so you have the right angle of your arms and your wrists on the keyboard, the right distance so that your eyes can focus on the terminal and the keyboards. Your posture is very important. So all these things come into play when you're trying to improve the worker's ability to do their job. We've also come up with entire engineering disciplines about how to have humans interact with their job. It's called human factors engineering. All right, so during the design of a new piece of equipment or a new system, a human factors engineer will help to ensure that the equipment and the systems are safe and easy to operate by the human beings. I always joke about it. If anybody remembers the Cadillac North Star engine from the early 80s, it was impossible for a mechanic to work on that. So I'd always tell people that was before human factors engineering came about. But now everybody takes into account the ability and the need of people to work with equipment. So human factors engineering is definitely becoming a big engineering discipline. So how do we engineer human factors that operate with safety? Okay. Being from Central Florida, we've all been to the Disney Worlds and Sea Worlds and where they have rides. Those rides, they typically have a placard that to ride this ride, you have to be this tall. And we know that that's because of the design of the safety features. You know, whenever you come up to that sign, don't let your kids stand on their tiptoes to meet that line, because if they're not that tall, these braces that are designed to hold the occupant in the chairs may not work properly. All right, so that's the design element of putting safety in. We can also put safety devices on equipment, such as the emergency shutdown buttons, if in case we have to shut something down. One thing to keep in mind, a lot of things are running with, they have centrifugal force behind them. So hitting an emergency stop removes the power, but it doesn't necessarily stop the tool from operating. You know, anytime anybody's operated a bandsaw or a circular saw, these things have to spin down. If you stop them immediately, it destroys the machine. So you have to understand the capabilities of that safety device. Don't expect it to, if you have to hit it, that the machine is going to stop immediately. We also have warning devices. One that I came across, and I just thought it was pretty neat, because I used to have to drive around the country a lot, get tired, and you get white line fatigue staring at the center line, and your head starts to bob. They actually have a nap zapper, which hangs behind your ear, and if your head moves forward, it'll give you a little electrical shock behind your ear to wake you back up. So that's the kind of things that can be warning devices. All right, and the other thing is training. You always want to have training for people to let them know what the issues could be and create procedures on how to operate and work with the machinery safely. Okay, so some of those muscular skeletal disorders we talked about a little bit ago, that comes, we fix it with ergonomics. The MSDs, or musculoskeletal disorders, they affect your muscles, your nerves, blood vessels, ligaments, and tendons. Like your whole body, everything that makes your body work can be harmed if you're not really careful. So workers in many different industries and occupations can be exposed to risk factors at work, such as lifting heavy items, bending, reaching overhead, pushing or pulling heavy loads, working in awkward body postures, and performing the same or similar tasks repetitively. You know, repetitive injuries are very predominant. Exposure to these known risk factors for MSDs increase the worker's risk of injury. So work-related MSDs can be prevented. The ergonomics of fitting a job to the person helps lessen the muscle fatigue, increases productivity, and reduces the number and severity of the musculoskeletal disorder. All right, so how to reduce these? This is the same way we look at reducing all safety-related issues in the plant. So the best thing, the most effective, is the engineering control. That engineering control means that the engineer designing the process actually makes the process or machine safe from the design, right? You implement physical change to the workplace, which eliminates or reduces a hazard on the job or the task, right? And that's the best way to reduce safety issues, to get things safer. Engineer out the hazard. One thing,
Mike,
go ahead.
Mike, yeah,
Yes.
sorry. I'm just sorry to interrupt you right
Yeah.
now, but we have just 2 or 3 minutes left for
Oh,
the hour. So I just want to
oh my.
pop in and say that we could do one or two things. We can just leave these last couple slides. There's only a couple more on this
Yeah.
particular topic. Um, and go ahead and close out, or if anyone wants to stay, we could continue going. But I think since there's just a couple more, let's scoot down to the end and ask if anyone has any questions or comments. Could you go down to slide 52 or 53?
Okay. All right. Thank you, Marilyn. I'm
Sorry
sorry I
about
got long-winded,
you
but
got a little
for
long-winded. Some
for
great
everybody
stories,
on,
by the way.
for everybody on the call, I want you to know a couple of things. Take away from this that if you know safety, KNOW, then you will have no accidents. But if you don't have any safety in your workplace, you better get used to having accidents, right? And as safety goes up, your risk goes down. One of the biggest things that we have in the industries is ladders. The risk is somebody stepping on the top of that ladder and falling off. An engineering improvement is the photo on the right where it has a guardrail around the top step. That's how we make things safer. We do it with engineering.
Yeah, thank you. So it's such an important topic in industry and our everyday lives, I think, for us to slow down, and make sure that we do things in a safe manner, even around the house and in the yard and while we're driving, as well as in the workplace. It's been great to see the evolution of this during my lifetime when it wasn't so important in years past, and now it's very important for most companies have a big emphasis on safety today to protect their workers and keep their production going and all of that. So I really appreciate your time and your great presentation today. I'm going to go forward one more or
Okay.
two. It's just, I didn't put
Anybody have any questions?
email on this. I meant to do that. Sorry about that.
Um, Mike, there was one question on whether you'd be willing to share your slides. We've got a couple of people who teach industrial safety, and they would like to use some of your slides if that's okay with you.
Yeah, yes, please. Would you guys be making them available to everybody?
Yeah, we can
I
do
have
that.
no problem sharing those with everybody.
Thank you.
Good morning. I just posted the link for the wiki page where your presentation and the recordings will be posted. It's right there in the chat box for everyone. You can have access to the presentation and all the material there.
Can you go to the next slide, Mike?
Okay, this slide.
So we also, yeah, that's it. We also have a few other resources that relate to this topic that you might be interested in, plus some handouts under the handout tag or tab on the right in the control panel. Some of the articles that Mike mentioned are posted there as in that handout section for downloading. We can put those also on the wiki page where Daniela just set the link in for. And lastly, this is the last session for this semester, for this spring. The recordings from our other two tech talks earlier in 2021 are posted here with the links to that. So you'll have those links also in the PowerPoint slides that you can go back and listen to those or share them with your class, as well as the tools that came along with those other talks. There were some handouts from those as well. And anything else, anyone, for the good of the group?
No, but I know a couple of positive comments may not have come up so that everybody could see them, but positive comments from the audience. Mike, very good presentation. So I wanted to make sure that you
Thank you.
knew that.
Thank you. I hope everybody enjoyed it and maybe got some new insight on OSHA. They're here to, OSHA was designed to help the workers in industry. So OSHA is a good thing.
There you go. All right, hopefully they'll be able to use some of those stories to make people aware of some of the, dangers and hazards in the workplace. So be more aware. It's always a good thing. Well, thanks everyone, and I hope you have a great weekend, and we'll see you again in the fall.
Okay, thank you very much for the opportunity to speak, Marilyn and Laura. I appreciate it. And if anybody wants to contact me with questions, just shoot me an email.
Yeah, there's his email on this page. So thank you all, and have a great day.
Okay,
Thank
bye-bye.
you.
Bye.
Yeah, okay.